Hello, so in our last lesson we went over how to solve a system of equations using either the substitution or the elimination method. So hopefully we're masters of that by now. The next step is, what if we have a real-world scenario, like a word problem, for example, that requires us to create and solve a system of equations in order to find the solution? How do we go about doing that? So in the last unit we went over how to do word problems where we had a single linear equation that would represent them. But it's a little bit trickier when you have to come up with two equations. So if you recall, generally with our single equation scenarios, we tried to put the equation into slope, intercept, form, which is in the form y is equal to mx plus b, where y will generally represent the dependent variable, m will represent the slope, x will represent the independent variable, and b will represent some initial value, so some value that is started with in the problem. So this, for a number of word problems on system of equations, we'll want to get two equations in this form. However, there is another form that will often be very helpful to us in solving systems of equations. So this form, I don't think it has a name, but it's very similar to what's called standard form. And in this form, we will have some number c, which is equal to some number a times x plus some number b times y, where a would be a rate, b would be another rate, and then x and y would each be variables, and c would be some value. So by looking at the language of a word problem, we will be able to tell which form of equations we want to use to solve it. So let's start with what, like a really classic word problem example. And I'll write it down on the board. So we'll say rental car company A charges an initial fee of, let's say, $20 plus 50 cents for each mile driven. And we'll say rental car company B charges, let's say, an initial fee of $50 plus 10 cents for each mile driven. And we are asked, find the number of miles for which the two rental plans will cost the same. So how do we do this? So our first choice is which form do we want to use for our equations. So there's a big hint in the language of the problem. And that hint is the word initial fee. So here we see the word initial fee. And whenever you see the word initial or starting, that's a huge clue that you're going to want to use slope-intercept form. Because when we see initial fee, starting value, that's a huge clue that whatever that number is going to be our initial value. So let's see. We're going to have two equations, right? Because this is a system of equations. We're going to have an equation for car company A and an equation for car company B. So for car company A, our initial fee is $20, right? So we already determined that that's the initial value. Our independent variable will be each mile that is driven. So we have M, and our rate is 50 cents per mile. And so what is this combination of numbers going to give us? It's going to give us the cost of the rental car plan. So that's our equation for rental car company A. We have the cost is equal to 50 cents times each mile driven plus the initial fee of $20. So you see, if he just drives 1 mile, it's going to be $20.50. If he drives, say, 10 miles, we would plug a 10 in here, and it would be $25, and so on. So hopefully it's clear how this equation represents the real-life scenario that's going on. So for car company B, we'll use the same process. So we're still looking at the cost. Our rate this time is 10 cents per mile driven, but we have a larger initial fee of $50. So now, if we want to see where these two equations are equal, we'll use the substitution method. So we have C is equal to this, and C is equal to that. So we want to set this equal to this. So we'll substitute this C with this equation. So using that substitution, we get 0.1 m plus 50 is equal to 0.5 m plus 20. So let's subtract 20 from each side, and let's subtract 0.1 m from each side as well. And that will give us 30 is equal to 0.4 m. So 0.4, I like using fractions instead of decimals. You can pick whichever one you like more. So I'm going to convert this 4 into 4 over 10, which is also equal to 2 over 5. Just say 30 is equal to 2 over 5m. Now in order to get m alone and find out what the number of miles is, we're going to want to multiply each side by 5 over 2. And that will give us 150 over 2 is equal to the number of miles. And that means that the number of miles is equal to 75. So you got to drive 75 miles to break even using these two rental plans. So if we wanted to see how much that would cost, we would plug the 75 in for the m in either of these two equations. So we can pick whichever one we like more. I think it's going to be a little bit easier if we use B. And that would just tell us that our cost would be equal to 0.1 times 75 miles plus 50, which would be equal to 7.5 plus 50. So our cost would be $57.50. So you see, we just solved our system of equations. We solved for the miles, and we solved for the cost. So that is an example of a system of equations that we might solve using slope-intercept form, which we're more familiar with from the word problems we were doing earlier. So now let's do another example. Move this whiteboard away. So let's say Jeremy let's see. Jeremy makes $200 by selling 8 books and 12 CDs in April. And let's say Jeremy makes $360 by selling 12 books and 12 CDs in May. So let's say if the price of books and CDs does not change between April and May, how much does each cost to buy? So you notice in this case, we're again going to have two equations. We're going to have an equation for April, and we're going to have an equation for May. This time, look, I don't see any language about any initial values or anything, like we did in the last equation. So that's a hint that we might want to use our second form, which a reminder is C is equal to AX plus BY. So now the challenge is to take these words and put them into two equations with that form. So in April, he makes $200, so we're going to call that C. And that is going to be equal to our rate, A, times the number of books, which is 8. So let's say I'll call it 8A, plus 12 times B, where B represents the number of CDs. So this makes sense because each book is going to cost A dollars, and each CD is going to cost B dollars. So 8 multiplied by the cost of each book plus 12 times the cost of each CD is going to equal $200, because we know that's how much money he made. In May, he makes $360 by selling 12 books and 12 CDs. So now we have 12A plus 12B. So he sells the same number of CDs, he sells 4 more books. So here you might notice, if you watched our last video on elimination, that these equations are set up very well for solving by elimination. Because if we just subtract this equation from this one, the B's, or the number of CDs, will cancel out. and we'll get 200 minus 360 is negative 160, which is equal to negative 4 times A. And the b's, 12b minus 12b, is equal to 0. So this equation is pretty simple to solve. We just divide each side by negative 4, and then we get 40 is equal to A, which is equal to the cost of one book. It's a pretty expensive book. I hope it's pretty good to read. So now that we have the cost of the book, we can use substitution to figure out what the cost of a CD is. So if we plug this value back into either one of our equations, I'll pick our first one, then we would get 200 is equal to 8 times 40, and then we would get plus 12b, 8 times 40 is 320, plus 12b. And then to solve this equation, we would subtract 320 from each side. We get 120, negative 120 is equal to 12b. If we divide each side by 12, we'd get each CD is worth negative $10, which is equal to the cost of one CD. So now we notice something funny. If the cost of a CD is negative $10, that means that he's giving away money with the CDs. He's saying, here's a CD and here's $10. So he really wants to get rid of those CDs. So I guess the music's probably pretty bad if he's giving away people money to buy his CDs. So maybe not the best worded problem in the world, but hopefully you can see the method that we use to set up these equations and solve for the cost of a book and a CD, and how we can take this real-world scenario and use numbers to represent it and solve for the costs. So I'd be happy to go over more examples during class or answer any questions during class. So I guess that's it.